little over time. Don't want to slip behind today because we've got lots to fit in. So we go from high speed to big data and the applications of D in that realm, an area of great interest to us here at Facebook, obviously. We have big data. So looking forward to this talk from Don Clugston, please. Welcome, everybody.
At DConf 2013, I gave a talk about metaprogramming. And I said that metaprogramming was a more impressive buzzword than big data, but that big data attracted more money. And as D makes a transition from a hobbyist and enthusiast language towards an industrial language, I think it's time for us to talk about commercial reality. And big data is already a success story for D. I want to say at the outset that although I've got real time in my title, I'm not talking about hard real time. The online advertising industry that we work in calls anything real time if the time is measured in milliseconds. So it's not the hardcore level which I'll be talking about here. Now, I have a bit of a, I must have some kind of insanity coming to Facebook to talk about big data. Facebook obviously has more data than almost any other company, and they're also far better known than we are. My little son, who's just learning to read, thinks that the ladder between E and G is called Facebook. In contrast, hardly anybody knows who sociomantic is. And I think even in the D community, people don't have a good idea about what we actually do. There are three common misconceptions about us, I would say, or reactions to us. When they hear that we do real-time bidding for online advertising, they think that we do some kind of trading, like high-frequency trading in the stock market. But actually we don't. We only buy, we never sell. There are also when people hear that we do online advertising, you can see the eyes glaze over. What could be more boring? And finally, since we are personalised, there are privacy concerns. And so I think the general reaction is, well, it's great that they use D, but why can't they be doing something a bit more sexy, like a program to zap aliens or something? But this is what we actually do. Real-time bidding for online advertising. And here's how it works. A user visits a web page, and while it loads, while the page is loading, the website holds an auction for the ad space. We bid on behalf of the advertisers that we're working for, our clients. If we win, we create a customised ad based on the information that the advertiser's given us. We transmit the image to the user. And the crucial thing is this whole process takes under 50 milliseconds. And I think that what we do is actually kind of cool. Based on all the data that we have, our challenge is to predict for each person currently online, for each product in our database, what the probability is that they would buy that particular product if we advertised it to them right now. Notice that the probabilities are very dynamic. For example, when somebody buys a washing machine, the probability that they want to buy a washing machine drops instantly to 0. And if we keep showing the person ads for washing machines hundreds of times a day for weeks and weeks, You'll think we are creepy and stupid. We want to show you what you're actually interested in without you feeling as though you're being stalked. And we also think that companies with a cavalier attitude to people's personal data that are trying to be in this business are not going to survive, because this relies on trust. We have to respect users' data. And a consequence of everything being personalised is that we supply a much smaller number of very high quality ads. We're only advertising at points where somebody will actually buy. Whereas the majority of internet advertising today uses carpet bombing tactics, where you are just bombarded with irrelevant garbage. These are the founders of our company. Thomas Nikolai, Lars Kirchhoff, Thomas Brandhoff. 5 years ago, they created our startup as a pure D company. And it has progressed since there. Despite our obscurity, the big data infrastructure that we've developed at Sociomantic Labs has, I think, potential interest to even much larger companies, even perhaps as big as Facebook. So the key factor of our system is it was developed from the ground up to operate on large data sets in real time. And it's currently delivering real-time performance on a deluge of data on a global scale. And it's for this capability that we were acquired at the start of April for a 9-digit sum. This is the first successful exit by a D startup, I think. And I think that our founders deserve a round of applause, showing what D can do. And I think they're online. The acquisition is by no means the end of our story. Quite the reverse. Our new owner, dunnhumby, is itself owned by Tesco, the world's second largest retailer, after Walmart, I believe. dunnhumby operates very successful customer loyalty programs for many companies, including the supermarket giants Tesco and Kroger. And dunnhumby has actually been in the big data business for 25 years. Very soon, Sociomantic's technology will use dunnhumby's incredible data set in real time. And we expect this to have a major impact on the advertising industry. And that will be a topic for next year's conference. Well, what is big data anyway? It's a bit of a childish term, really. I think if I was trying to impress people, I would pick a Latin or Greek term. But nah, it's just big. And how big is big data? The common definition that you'll read is what people say, too big to handle easily. Too much for existing technology. The thing about that is it changes with technology. As technology progresses, what's big gets bigger and bigger. But I actually don't think this is right. I think there's been an interesting phenomenon in the last few years. And that is, we've reached the point where we're getting things on a humanity scale. Most data has traditionally come from human input, and there's only 8 billion of us. And 8 billion is no longer a big-sounding number for a programmer. 1 byte for every person on Earth is only 8 gigabytes. And 8 billion humans times 1 megabyte is 8 petabytes. The maximum amount that one person can read in a day is about 1 megabyte. So 8 petabytes is kind of the total conscious output of the planet. And high quality data is really rare. The entire Library of Congress is about 15 terabytes of text. Now you can buy a 2 terabyte hard disk for 100 euros. And so we're at this interesting point in history where we have the hardware to handle this human level of data, but the software is not up to it. And so that's why we're here. That's why we've still got jobs. The interesting thing about big data being outside of human scale is it has to be machine generated, and a consequence of that is it has no natural limits. It will inevitably get bigger. At Sociomantic we have a rule. We try to keep everything ready for a factor of 10 increase, which is tough, and we don't always manage that. In fact, almost never, but it's always going to grow. Also, because humans can't cope with these levels of data, the information density is very low. An extreme case of this was at CERN, the Large Hadron Collider, processing 15 petabytes of data to determine that the mass of the Higgs boson was 125 gigaelectron volts, 6 bits. Now that's a hot compression ratio. And also, another factor of big data is that it typically has a very high locality of reference. Because it's machine generated, it's normally associated with a particular machine. It may be from an IP address, a geographic location, a particular sensor, whatever. A key point I want to make today is that big data is a natural market for D. There are 3 reasons why I think this. Firstly, from our experience at Sociomantic. Secondly, because it's a performance-oriented field where not many languages are suitable. And thirdly, because there's a level of immaturity about it. It doesn't have the same entrenched positions that many other fields do. I think people here perhaps don't have a good understanding of how much data we're actually dealing with at Sociomantic. We participate in 10 billion auctions per day. So that's a similar kind of number to the amount of Google searches that happen. And we respond to each of these auctions within 2 milliseconds in most cases. We have 700 million unique visitors per month, and that's about 30% of the world's internet using population. 50% of the world's internet using population is in China, and we have very few of those. And we have 1 billion images, which are all servable in under 50 milliseconds. And they're all refreshed within a couple of weeks. And we're operating on a slice of the world economy. We're in the retail, travel, telco and finance sectors. And we're advertising on desktop, mobile and social media. So I believe we have a fair amount of credibility here. Since 2013, we've increased our range from 50 to 60 countries. We now have 13 offices, I believe. We opened ones in Sweden, India, Singapore, Italy, Turkey. Got a presence in Indonesia and Chicago. Doubled our number of employees. We've got even more. We're even more crazily international, with 35 nationalities, 26 languages, which divided by the number of employees is extraordinary, I believe. And all this growth of the company is not from external investment. It's still based on the initial investment, which is €3,000. Market capitalisation of €3,000. And our back end is still 100% D. Always has been, always will be. The second reason why I think it's a great opportunity for D is that it's high performance field. And what high performance means has actually changed over time. In the 60s to 80s, code was always CPU limited, and the way to write fast code was to minimise the number of instructions. If you've got less work for the processor to do, then your code will be faster. But that's actually not true anymore. In modern times, you're far more likely to be memory limited. And we no longer have slow external storage, we've got high-speed internet with an incredible amount of available data. Performance today is much more likely to be dominated by the latency of your I/O and your memory. Even the modern DDR4 RAM chips, they run at 30 megahertz. It's barely improved since the late 80s, despite the massive improvements in processor speed and available data. And on a x86, a third level, a level 3 cache miss, which is your worst case, that in the time that it takes for you to get that data, you can execute 1,000 CPU instructions. And a consequence of this is that micro-optimization rarely matters. You have to get your algorithm right, and then you have to get your memory patterns right, and only then does using the CPU matter. And so a high-performance language must be good at organising memory. You must have control over how you are using your memory. And still, nothing beats an array for locality of reference. D is a big performance win for Sociomantic for 3 reasons. Firstly, we've got direct binding to C libraries, so we can reuse existing highly optimised code. Secondly, metaprogramming support, so that we can do complex structures efficiently. And thirdly, array slices. Now, I made these 3 points in my talk last year, but I was a bit, just intuitively, array slices are important to us. And I'm a scientist, and I don't like these vague kind of statements. And I got interested. How much do we actually use array slices? So I grepped through our code, and I also, as a comparison, I also grepped through Phobos for some commonly used language constructs. And I thought the results were pretty interesting. I use equality as a benchmark. 5% of lines of code contain an equality test. Not equals is negligible by comparison, 1/10 of it. The interesting thing was that creating a slice was 4% of the code for both our own code base at Sociomantic and also at Phobos, also in Phobos. And the fourth and fifth lines there indicate probably declarations. So a large fraction of there's also a lot of code involving slices of strings. The conclusion from this is 1 line in 20 one line in every 20 lines of D code contains a slice operation. If you are programming in D, you are thinking in slices. It's that important. 5%. It's more than half as much as equality tests. And if you're using a programming language which doesn't have slices, then you're not thinking in this way. I know that when I was programming in C++, I was not thinking in terms of memory blocks, pointer and the length. So this feature of D is changing the way we think. And it turns out to be a good match to the machine. The third reason why big data is a great opportunity for D is that it's not a mature field. The solutions are not really entrenched. Typically, if you start off with a traditional database, as it gets bigger, you'll be using a relational database. But it turns out to be not work very well for big data, and people are abandoning it. Basically, because the strength of a relational database is that it destroys locality of reference. And that gives you wonderful properties for data integrity, and you get the relational calculus, but your performance suffers. And at this point, in any big data talk, the speaker normally says that they use Hadoop, and they explain how Hadoop solves all their problems. Now, I'm not going to, because we don't use Hadoop, and it doesn't solve all our problems. But I better explain what it is. Apache Hadoop is an open source Java project inspired by Google's Big Table. And by now, it's a whole suite of products, but the core components are a distributed file system and a distributed query engine. The query engine is based around a concept called MapReduce, which is related to the functional operations map and reduce. First, you map the query to a cloud of servers, and then the result is reduced. The result's combined from all the servers, and it uses a DSL. Which is compiled and run on all the servers. And this works well because it gives you a way of preserving locality of reference. And although it doesn't quite have the rigor of SQL, it's quite powerful and flexible. Hadoop is exploding in popularity. So, is Hadoop the one-size-fits-all solution that solves big data? Well, hardly. The problem is that it was developed for batch processing, not for real time. Hadoop queries often take hours to run. It's a fantastic tool for the case where you're doing data mining on a huge batch of data and you want to run sophisticated analysis on it. But hour-long queries are completely useless for real-time applications. As I mentioned in the introduction with the washing machine example, the data that you're analysing is constantly changing in real time. You just can't batch that stuff. And there's a host of groups trying to solve this problem. There's a mob in Cambridge, for example, who've made a drop-in replacement for Hadoop that they claim runs 100 times faster. 100 times faster. Speed-ups of that magnitude are a sure sign of an immature field. If you can get a couple of magnitudes of improvement, there's lots of potential for anybody to jump in. And another area where the immaturity shows is in visualization. Everybody working with big data would love to visualize their data, but there doesn't seem to be any consensus on which tools to use to do that. It's a great opportunity for innovation, and thus a great opportunity for D. And the final sign of immaturity is the chasm between rhetoric and reality. There was a survey that Gartner did last year that said 64% of firms want to use big data. They're planning to use big data. 8% have started doing something. Well, so it's a great opportunity for D, but there's a problem. Garbage collection. And really, D's standard garbage collector is a performance nightmare. On our system, it gives stop-the-world freezes of 100 to 250 milliseconds. When we've got a total allowable limit of 50 milliseconds, including internet latency, 250 milliseconds just doesn't cut it. Last year, Leandro Lucarello, also from Sociomantic, gave a talk about our concurrent garbage collector. It's been running 24/7 for 3 years at Sociomantic on all of our servers. Performs well, and it really should be in the standard library. It's our magic bullet. It gets our stop-the-world freezes down to 5 to 10 milliseconds, depending on the application. And we get constant times. So, problem solved. Everybody's all worried about garbage collection, and Sociomantic is living in paradise. Well, okay, our garbage collector only works on Linux, but most of you are on Linux, so aren't you in our paradise? But unfortunately, it's not that simple, because big data produces really big garbage. I'd like to introduce the idea of thinking about this in big O notation. For every n bytes of input that come into your server, so you get k times n bytes allocated. K is some constant, some small constant. So, for example, if n is 1 terabyte per day, which is typical for some of our servers, and suppose each byte that comes in results in 10 bytes allocated, then your garbage collector has to collect 1 gigabyte of garbage every 8 seconds. And I really think that's a tough call. And it's not as if you can defer collection. The supply of data coming in is relentless. And a practical question. We've talked about these garbage collector getting better. When will that happen? Well, I think optimistically, maybe in 5 years. Maybe we'll do better than that. But I think realistically, if you want to make money using D now, you have to live with what you've got. And I also wonder, does a perfect GC really just mean as good as malloc? Because if you've ever, certainly it's been my experience that I've seen programs where when I've profiled them, I found that the performance bottleneck was free. Malloc isn't fast. If you're comparing your GC against malloc, then the bar is low. So we do a different approach. We demand order 1 allocations. For every n bytes of input, k is 0. 0 bytes are allocated. And we don't push it off to malloc either. It's in our code, it's common for us to go in the debugger on a running process, put a breakpoint on GC malloc, and it will wait for a minute before it is called. This is on a server running with 80% load. What do you need to do to achieve order 1 memory allocation? Well, you don't have to do this no GC. It is possible to actually allocate. Just the simplest example I could think of. If you have a reference char star, you can append to it. Yes, it does allocate, but the total number of GC root nodes doesn't increase. You had 1 before and you've still got 1. Nothing is passed off. And because the calling code retains the pointer to the allocated buffer, it has a chance to use that memory again. And so all of our code works by reusing buffers. And the fact that we allow buffers to increase but not decrease means that the memory usage, and it starts off initially at a low value. In the short term, it rises rapidly, and then it asymptotically approaches the working set required by the program. What this means in practice, effectively this means that we have fixed size buffers as if they were statically allocated with a fixed length, but we don't have to know what that length is. And so we retain correctness performance. And we don't allow any other memory allocation. That means we have no heap activity except at the highest program levels. Yeah, it's really extreme, it's hardcore, but it works. And it's not as painful as you might think. But it is painful. A problem with it is that if your low-level functions require all buffers to be passed, then it just leaks up. The buffers leak through the APIs. High-level code needs to expose the buffers required by the low-level code. And so in practice, that means you do have to do a lot of refactoring. So I think that realistically, only fairly low-level libraries can afford this. And it can be quite difficult to retrofit existing code. At the current time, we're completely unable to use Phobos because it just has too many unavoidable allocations. And because we're going for order 1, not simply a reduction in memory allocation, we just can't tolerate any of it. So this is a challenge for the language, I think. I want to finish with 3 examples which are quite ugly. These are 3 things which for us are a constant ugliness in the language. So these are 3 bugs which crash our system. So what's wrong with this one? Well, obviously there's no bug, but it allocates memory unavoidably, creates activity for the garbage collector. So the situation D has a built-in operator that requires a garbage collector that we don't yet have. And this also applies to associative arrays and closures, and various other things. So we've got these in our code, the concat operator is banned. And this is pretty awful to do that for such a primitive built-in function, built-in operator. Second one, can you see what's wrong with this? No, well, I'm assigning it. No, there's nothing wrong with this code. Well, yeah, I'm just doing a silly example, but this crashes our programs. Why? Stack Overflow. We use fibers. Our stacks are small. We run with a stack of 4 kilobytes or 8 kilobytes in our fibers. And I've put this up here because people have discussed the idea of memory allocations in Phobos, perhaps using a locker to store on the stack. Now, we can't use that because we have these tiny stacks. And final example, and this one really is a bug anywhere. What's wrong with this? Yes, exactly. B length may be 0, and the problem is length is unsigned. That is an unsigned comparison. And, you know, that's unsigned and unsigned. People have requested signed, unsigned mismatch errors, but this is not a signed, unsigned mismatch. This is unsigned, unsigned, and you've got an unsigned comparison. But that is not what you want. And this is a real example from our code, greatly simplified. It was only and it wasn't as obvious as this, but in rare seg fault on a particular condition when this goes negative. Any dot length with subtraction in it is usually a bug. Yeah.
I don't think the length of subtraction is a bug. I think subtraction within signs is usually a bug.
Well, I think the only time you're going to get away with length with subtraction not being a bug is when it implicitly gets converted to int somewhere along the way.
Or it should just be signed.
That's my opinion. I think it's really dreadful that length is unsigned. This kind of physical lengths are not. If you measure something, that's not unsigned means you get wrap semantics. When you measure something, length of something is an integer. It's not you don't want wrap semantics. So length really should be an integer. I'm not sure that I have a solution for this, but I think this is a really sore point in the language. And I think slices are beautiful in D, and this is just awful. So why is order 1 big data possible? The reason why it's possible in our code at all is that only the big data code needs to be fast. There's a certain fraction of your code which is dealing with the constant, relentless input data. You also have other stuff in your code. In our cases, we have control data from other databases. But it's response to human input. It's very small in comparison. That does not need to avoid memory allocations. And most of the code deals with rare events. The bit that's dealing with the big data code is quite small. We can only do it because we have these short stop the world pauses from our GC. And it requires in our libraries that they never perform mandatory allocation. Not hardly ever, but never. Because if you get an event which is rare and then multiply it by 10 billion times, it's not rare anymore. On our system, there is no such thing as a rare event. 1 in a million means every 3 seconds. So here's the bottom line. Is it worth it? Well, based on public data which everybody's published in their financial reports, our infrastructure costs, our total server costs, etc., are 4 times lower than the rest of our industry when normalised for revenue. We're paying 20. So, roughly speaking, we're using 1/4 of the number of servers of everybody else. So, if you remember one word from this talk, it's the word ruthless. Big data is a key market for D, so we should be ruthless about memory efficiency. Thanks. And we're hiring.
Questions for Don? Don't be scared. He's going to be ruthless on memory, not everybody.
Not anything else. No.
This time I'm really going to ask a question that everybody else knows. But you mentioned about relational databases destroy locality of reference. Could you just kind of clarify what you meant by that?
Okay. Well, with a relational database, you have every row in the table is independent. And so if you, say for example, you have a sensor which is storing data in a relational database and you have a time field. You have maybe time in seconds and sensor number. And then you store this in there in a table. You've got all your times. They can be any, there's no order in the columns. The act of putting it in has just, you've removed the locality aspect of it,
Okay, I see.
the sequential.
The sequentiality
Yeah.
is what you're saying. Okay, well, that was easy. Thank you.
How do you compare with columnar stores? Those should avoid some of the, at least the striding aspect of non-locality. Do you use any column-oriented store?
No, we don't. It's not that we tried those things. The system was originally designed to be, they thought long and hard about what is the fastest possible way to do all this stuff. And it was designed from the ground up.
Yeah, let me give it to David.
Yeah.
So on your buffer optimization where you don't allocate memory, another way you can handle this, and I don't know if it doesn't interact well with the way you're doing threading, but you can use thread locals to just keep local buffers, and that way you can declare them near the code. I mean, so I'm speaking about C++, we use static thread local variables, and that will let you kind of keep it. It means your interfaces and APIs don't have to bleed the buffers all over the place. Just wondering about that.
Well, we don't use threads at all. Everything is fibers. So we don't. Fiber local storage would be really nice, but we don't have that.
So you said that Hadoop and all the other pieces of potential usages for storage, you don't use them. What do you use to store all this?
We use a system we've written ourselves in D.
Okay, well now I have two short questions, and they're not technical. Number one, are you going to share your storage system with some of the rest of us in the D community?
It has actually been mentioned internally, but at the moment it's such a competitive advantage to us that I can't see it happening in the short term.
Right. Because of that, that makes all of us want to work for you. And so my next question is, what do you have against the United States, and especially near where I live?
Well, all of our development is in, although we have offices all over the world, all our development is in Berlin at the moment.
Questions? James, could you take any online questions if there's any? All right. Last question, and then we'll take online questions if any. All right. Anything, James? Okay. Well, we're struck with awe. Let's give again a hand to Don Clugston. Thank you.